You're welcome. This is the House of Shedo. Once again, we are going to look at Math111. Please subscribe so that you can get more quality videos from us. So today we are going to be looking at this particular question. We have on the board cos 15 degree minus cos 75 degree. So how are we going to do this? Now, when you look at the option, you can see that most of the answers are actually in the form of roots. So the approach to this will be to work with special angles, those angles that are easily expressed as rational numbers, that are easily expressed as rational numbers and irrational numbers. So let's see how we can turn cos 15 to a special angle. So we can write cos 15 as cos into 45 minus 30. So 45 minus 30 gives us what? 15. And then we can also write cos 75, we can write as 45 plus 30. And remember, 45 degree and 30 degree are two special angles that we already know how to express in terms of irrational and rational numbers. So what is cos 45 minus 30? We are going to use the compound angle expansion of the cosine of this. So using the compound angle expansion, we have this should be cos 45 sine 30, then plus, when it is minus here, it should be plus here, sine, okay, this should be cos 30, then sine 45 sine 30. Now we do the same thing to the other side. We have cos 45 cos 30, and then we have, put this in brackets, we have minus sine 45 sine 30. Okay, so this is what we have. So we can open up the brackets. We have cos 45 cos 30 plus sine 45 sine 30. Then this becomes minus cos 45 cos 30. Now minus multiply minus gives us what? Plus. So you have plus sine 45 sine 30. Now when we look at this, we see that this term and this third term are the same. We can cancel because of the minus. So when you minus, they cancel each other. Why this term and this term is also the same, but because of the plus, we are going to plus both of them together, which will give us 2 sine 45 sine 30. Now, this is our simplified expression for this when we expanded using the compound angle for cos A plus B and cos A minus B. So what I'm now going to do now is I am going to rewrite sine 45 in terms of a special, relating it to the rational or the irrational number, because this is a special angle. Likewise sine 30. So we have 2 times, what is sine 45? Sine 45, when you look at the right angle triangle, 1 root what? Root 2. So sine 45 is 1 over root 2. Then times what is sine 30? That is 1 over 2. So we have 1 over 2. So 2 cancels 2. We have 1 over root 2. But remember, this is root 2, which we are to rationalize, so that we shouldn't leave root 2 as a denominator of that fraction. So let's rationalize this. When we rationalize this, we should have 1 over root 2 times root 2 over 2 root 2. This gives us root 2 over 2. So this becomes our answer, which should be option C. So we are going to look at this particular question. We are still on trigonometry. So we have sec theta equal to 2, and then we are given this particular range. This simply means that our angle theta must be less than 90. Pi over 2 is 90 and must be greater or equal to what? 0. So, but what they ask us to actually find is sine what? Theta. Okay, now let's see. Now the idea is to see how to get to know what the value of theta is from this particular expression, so that we can now make a substitution and obtain sine what? Theta. Now this is sec theta equal to what? 2. There is no much direct relationship between sec and sine. It is easier to see a relationship, much easier to see a relationship between sine and cos theta. So let me see how to rewrite this in terms of cos theta. So I'm going to write this sec as 1 over cos what? Theta. And then I will have my 2. Then if I should rearrange this, cos multiply, or take the inverse of both sides, you should have cos theta equal to 1 over 2. So this implies that theta is the cos inverse of 1 over 2. Now, what is cos inverse of 1 over 2? That is the same thing as saying cos 0.5. That should give us 60 what? Degree, because cos 60 is actually 0.5. So now that we have gotten our theta, we can now make a substitution to sine theta. And then when we do that, we should have sine theta is equals to sine 60. And what is sine 60? Sine 60 is root 3 over what? 2, as one of the special angles. So that gives us our answer to be B. So we are going to continue on trigonometry question. Now we have simplify sine to the 4th power theta minus cos to the 4th power theta. Now, one of the ways we can do this is to form a binomial expansion of sine theta minus cos theta always to the 4th what? Power, and then write the expression for the binomial expansion of 4th power. But that is going to be quite long. So what I'm going to do is I'm going to use the knowledge of what we call difference of two squares, because I'm seeing something here. I'm seeing that we can rewrite the first one as this, and then we can rewrite this as this. So this gives us the difference of two squares. And don't forget that the difference of two squares, which is that a square minus b square, is a minus b, then a plus what? Plus b. So when I use it here, I should have, if we consider sine square theta as the a and the cos square theta as the b, I'm going to have sine square theta minus cos square theta, then into brackets sine square theta plus cos square theta. Now, this is a well-known result in trigonometry, that this is just 1. So if that is 1, so we have this as a resulting expression. So how are we going to do this now? It's not yet looking like any of the options, so we need to simplify further. So one of the things that we are going to do here now is that we are going to see how to rewrite this cos square theta and this sine square theta. And I think one of the tricks that we are going to use is we are going to use this particular expression that says cos A plus B is cos A cos B, then minus sine A sine B, which is our compound angle expansion. Okay, so if we use this, we can say that cos theta plus theta is cos theta minus sine theta sine theta. So this is cos theta plus theta is 2 theta, and this is cos, when you multiply this is square, and when you multiply this is what? Square. Now if I interchange sides, I should have cos square theta minus sine square theta is the same thing as cos 2 theta, but then you can see that our expression is actually sine square theta minus cos square theta, not the other way around. So what I'm going to do is just to introduce negative to both sides of the expression. Now when I introduce negative to both sides of the expression, I have here that sine square theta, negative cancels this one, then we have minus square theta, then minus cos 2 theta, which seems to be the answer, which is our C. So let's look at this. One of the solutions of the equation 2 cos square x minus 3 sine x is equal to 0 in the interval is, now this is actually an equation in trig. So we are going to see how to solve this equation to obtain the value of the angle, which is x, and then we are going to make sure that our solution lies between this particular interval. That means it runs from 0 degree to 360 degree, which is 2 pi. Now we have 2 cos square x minus 3 sine x equals to 0. Now when you look at this, you see that we have two different trig function, cos and sine. It will be much easier if we work with only one trig function. So what we are going to do is to see how to recast cos square x in terms of sine x. And don't forget the famous cos square x plus sine square x equals to 1. So when we use this, we can rewrite this part. We can rewrite it as 1 minus sine square x. And then we can open up the brackets. We have 2 times 1 is 2 minus 2 sine square x minus 3 sine x equals to 0. Now if we rearrange this, we should have multiplied through by negative, we should have 2 sine square x plus 3 sine x, then minus 2 equal to what? 0. Now what is this looking like? It is actually looking like an expression, an equation in quadratic form. You can see this particular expression here is of the order of 2, and then we have this same expression here, we have it here, which is something like this. Remember, a general quadratic expression can be written in this form in terms of x as the variable. So you can see what I'm saying. If you have the same variable x, you have to the order of 2 and to the order of 1, and then this is a constant, and likewise 2 is just a number which is a constant. So we can treat this particular equation as a quadratic equation and then we can solve quadratically. So to do this, I'm going to just use the formula method. So this becomes sine x equal to minus our b here is, this is our a, this is our b. So this is minus 3 plus or minus root b squared minus 4a and our c, then over 2 times a. So sine x is minus 3 plus or minus. So this is 16 plus 16, and this is 9. 9 plus 16, that gives us 25. Now root 25 is 5, and then we have over 4. So this gives us sine x is minus 3 plus 5 is 2. 2 divided by 4 is half, or sine x is minus 3 minus 5 is minus 8 divided by 4 is minus 2. So let's see how to obtain finally the value of our x, which is our interest. Now we have two different expressions to work with, but let's work with this one. Now this is going to be x is a sine inverse of half, which is sine 0.5, which is 30 degree. And in radian form, what is 30 degree? Don't forget, 1 pi rad is 180 degree. So 30 is simply going to be this is going to be 30 pi over 180. So this cancels, this here 1, this here 6 is pi over 6, which lies in this particular range, because this is from 0 degree to 360, and 30 degree is within this particular interval. So the answer is this, which is one of the solutions. This will also give us another solution. So we continue with our trigonometry questions. Now we have 1 plus tan 15 over 1 minus tan 15. Now let's see how to evaluate this particular expression. Now we are going to see what should be the value of tan 15 in terms of special angle. Of course, tan 15 is not readily gotten in terms of special angle. So we are going to use two angles that we are well familiar with, which is 45 and 30 degree. So tan 15 is the same thing as tan 45 minus 30. And definitely tan 45 minus 30 can be written as tan 45 minus tan 30 over 1 plus tan 45 tan 30. Now this follows through the particular expression that says that tan A minus B is tan 45, tan A minus tan B, all divided by 1 plus tan A times tan B. Now, what is tan 45? Tan 45 is simply 1. And what is tan 30? Tan 30, tan is sine theta over cos theta, and sine 30 is 1 over 2, while cos 30 is root 3 over 2. So definitely we'll be having 1 over 2 times 2 over root 3. So that gives us 1 over root 3. So this gives us 1 plus 1 times 1 over root 3. So we have, when we simplify the up, we have root 3 minus 1. And then when we simplify down, we have 1 plus 1 over root 3. Now let me take this upward. And then I have root 3 minus 1 over root 3. Then this one down, when I simplify it, I have root 3 plus 1 over root 3, which can be written as root 3 minus 1 over root 3 times root 3 over root 3 plus 1. So this cancels this. We have root 3 minus 1 over root 3 plus 1. So that becomes our expression for tan 15. But remember, this is what we want to evaluate. So we are going to carry the expression for tan 15 and return it back to this particular expression. And when we do that, we will have 1 plus, what is our tan 15? Tan 15 is root 3 minus 1 over root 3 plus 1. And then you have over 1 minus, as you have here, you have your root 3 minus this over root 3 plus this. So how do we go about this? We can simplify these parts. We can also simplify this part. Now, to simplify this, we can, okay, let me see. Let's wipe this off. Okay, now this becomes root 3 plus 1 plus root 3 minus 1 over root 3 plus 1. Then we have the denominator becomes root 3 plus 1 minus root 3. Now this minus is going to actually affect this. So we have plus 1, then we have over our root 3 plus 1. So what do we have? We have this can deal with what? This. And then 1 can deal with minus 1. And then root 3 can deal with root 3. So what do we have at the end of the day? We have root 3 plus root 3, that is 2 root 3 over 1 plus 1, that is 2. And then we can cancel 2 here and then 2 here. So our final answer becomes root 3. So B should be our final solution.